Okay, I thought this is section 3.10. I thought we'd look at 7 and 9. Sometimes people have a hard time thinking from these diagrams. These are just, can't even remember what they're called, but they're showing how the points match up. Now, I know that my domain is on the left. I'm going to put a D above it in red because it is, this is our domain. I'll put a big D up here even though it's going to kind of run over. And the reason I know it's the domain, it shows that you're putting a point in and it's giving you out 1. Your input is 0, and the fact that the arrow goes to 1 tells us we have the point 0, and when you do something to it, it ends up being 1. But then we have 0, comma 2, and we have 0, comma, that's a 2, supposed to 3, kind of hard to read, I know, but just you have to listen, and then 0, 4. Now, is this a function? By the way, before we answer that question, let's look over here. If the input over here is the domain, then the output, I wish this would pick up my writing better, output over here, this is the range, so we'll just put an R for range. Your ranges, your domain is your x's, and your ranges are your y's, usually in functions, okay? Now, what does it take to make it a function? You have to have, each x can only have one y. Another way of saying that, if you've got a table or a chart like we've got here, or even points, is check the x's. Are they all different? Let's look at them. No, they're not. They're all the same. Since there's not each, you have to have each x be unique. In other words, you can't have 0 go to 1 and 0 go to something else like 2 or 3 or 4. So this is a relation. This is not a function. One other way I could have told that is if I actually took the time to put it on a graph. Because I don't know if you remember this, but the vertical line test tells us if we have a function or not. So let me graph these in green just real quick. We've got, okay, this is going to be awfully hard to do. I'm going to give it a shot, but you're going to need to show me some grace. There's like 0, 0, 0. Let's pretend that's 0, 1, and then 0, 2, and then 0, 3. They're all on the y-axis, in other words. Now, if I do the vertical line test and I draw a vertical line there, didn't I just hit, I hit actually 4 points, but all it takes is more than 1 point. So this is not a function because each x is not unique or each x is not different. Now let's go look at number 9. Number 9, if it helps, write the points this way, because I know this is called a mapping diagram. That's the name for it. This mapping diagram can be kind of hard to read for some people. I know I have a little bit of trouble thinking about it. I'm just not real visual. No, well, I don't know how to say it. This is hard for me. If it's hard for you, I understand. We have the point x is 1, because remember this on the left is our domain, and on the right is our range, and so the domain is our x's, and our range represents our y values. So we have the point x is 1, y is 2. But we also have the point x is 2, y is 2. Is that okay? Does that mess us up already? No, because look at the x's. They're different. It doesn't, you know what? It doesn't make a bit of difference about those y's. They can all be the same, and it's still a function. What matters is are the x's all different. Well, then we have 3 goes to 3. So far, our x's are all different. We're looking good. 4 goes to 4. Hey, that's a different x. We're still good to have a function. And the last one is 5 goes to 4. Are your x's all different? Remember, your x's are on the left side of your point, just like they're on the left side of these diagrams here. Yes, they're all different. Therefore, this is a function. So the answer is yes, it's a function. I don't know why I wrote that in yellow because it's hard to read. Function. Now, if I were to go graph these, we could also tell with a vertical line test it was a function. That's the thing. In math, you got all kinds of tools. We can look at the x's and see if they're unique. We can look at a graph. If I'm going to have to do this just generally. You're going to have to give me grace again. 1, 2 is about right there. I actually accidentally graphed 2, 2. Well, no, it's just not taking where I'm putting it. 3, 3. Let me do this again in red because I'm afraid you're going to think that there's 2 points. Let's say 1, 1 is there. 2, 2 is there. No. 2, 2 is there. No, I can't get it to take where I want it. 3, 3 is actually a little higher. 4, 4 would be around here, and 5, 4 would be, actually graph 5, 4. Let me do 4, 4. I just can't. I'm putting this thing down, but the tip is too big to be that small and pick up accurately. If you were to do this on your own paper, what you could see that is if I draw a vertical line, I'm only going to hit one line. I can't even make it hit with a stylus. But anyway, 9 is a function. Yes, it passes the vertical line test if you put it on a graph. Can't get it to even pick my letters up when I'm writing them. Okay. Okay, on the written exercise, number 3 is a little tricky, so I wanted to make sure we went through it. What I would do with this first before making a decision about this is rewrite the points, because they're making you do a little simplification here. This is still the point -2, 1. At first you might think all the x's are you might think, oh, it's not a function, because look, there's a -2 there, but really there's not, because look what happens. What is the absolute value of -2? Oh, it's just 2. So I have 2, 0. Now over here I've got -1, and what's the absolute value of -2? Oh, it's just 2. And then down here I've got the absolute value of -1 is really just 1, -2. So they were trying to trick you a little bit here. So if you have to simplify something to figure it out, simplify it. And now you look at them. Are all our x's different? There's a -2, a 2, a -1, and 1. By the way, that would be the elements of my range if I wanted to my domain. If I wanted to write my domain down, it would be -2. I'm going to put them in order, -1, 2, and 1, just looking at those green circle things. They're all different, so yes, this is a function. All right, 7 is a little confusing too. First of all, there's the notation. When they give you some things like this, they're saying, okay, we got points. Let's just kind of take this apart. We got points, and our points are going to have an x and a y in them. Kind of normal, right? And our equation is the absolute value of x equal absolute value of y. So that would be like points, like absolute value of 1 equals absolute value of -1. Okay, something like that. And at the same time, the absolute value of x has got to be less than or equal to 1. What does that mean? Well, we got to kind of go back to where we did some stuff with inequalities. If I've got x right here, that means it could be 1 unit away this way, but less, equal to or less, so I could shade in. I'll tell you what, let me do my shading in a different color. So let's say that's 1. It could be 1 between, let's say this is 0, okay. Or it could be this direction 1 unit, as long as it's this much or less. And so it would be between -1, okay. Now, we need to go back up, and if I shade, it means my answers could be anywhere in here, right? Well, now, we go back up and read the directions. It said that they're integers. That means those are going to be whole numbers. So I'm only looking at -1, 0, and 1 to plug in for my domain. And they want to know, is this a function? Well, we got to see. This part right here just tells us what our kind of possibilities are for our x values. This right here is the equation, so let's do it. Okay, so we're supposed to say if it's a function. Okay, what if I wanted to? It's not. Okay, and here's why it's not. Let me show you. What if I plugged in x is -1, and I plug in x is 1? Let me do this. -1. Let me make both my x's. I'm going to try it. X is -1. There's two possibilities, because isn't the absolute value of -1 equal to -1? The absolute value of -1. So that would give me the point -1, -1. Because remember, this just means 1 equal 1. Yep, that's correct. But look down here. What if I put a 1 in here? What's the absolute value of -1? It's 1. What's the absolute value of 1? It's 1. Oh. -1 has the same absolute value as -1, and -1 has the same absolute value as +1. So that means that I have repeating x's. These are different y's, but that's the same x, so this is not a function. That took a little thought. Honestly, I think this one would have been easier if we looked at the graph. If I put an absolute value of -1 is equal to absolute value of y, that would have been equal to -1, or it could have been absolute value of -1 is equal to absolute value of -1. We would have had 0, 0. We would have had 1 is equal to absolute value of 1 is equal to absolute value of 1. Absolute value of 1 is equal to absolute value of -1. You could see this would fail the vertical line test if you graphed it. I'm not sure that graphing is probably helping you any, but anyway, I'm hoping that maybe you could see it a little bit better. Okay, let's go to number Now number 25, actually I'm going to put that on a different video just because the video is getting a little long.